So yeah, it's kind of hard to believe it's been a year since the last time that we were here. Things are moving really fast. I went back this morning and looked at the deck that I presented last year just to see how wrong I was, because 2 out of 3 times, hey, how are you? That'll happen. And when I was talking with Tom last year about the content for the presentation, I said, what should we talk about? And he said, talk about things that are real. And software defined anything in 2013, just how real was anything. So what I'd gone back and looked at was some trends, and one slide that I called out said that we're going to call 2013 as the year that software networking really got its official start, even though there's been software networking that's been going on for a while. And the reason I called out 2013 was for a couple of reasons. One was that's the year that we really saw as from Viata was acquired by Brocade, and a virtual routing company about late 2012. But around 2013 was when we first saw the real large-scale deployments of software networking going on in clouds like Amazon and Rackspace and SoftLayer and a whole bunch of other ones around the world. The second reason for calling out 2013 is that's when you saw more companies coming forward with software-based solutions. And the third reason that I called out 2013 was because it was about this time last year that we did the session, and just a few months prior, the largest service providers in the world gathered at Darmstadt, Germany, at the SDN OpenFlow World Congress, and posted a paper called NFV, Network Function Virtualization, a call to action. And it was, it was really a shot heard around the world. You got the largest buyers of infrastructure in the world came together and basically told the industry, you're not giving us what you need. Our business model will not survive with this kind of mainframe era, all black box infrastructure model that you're giving us. We demand that you give us infrastructure that is software based on industry standard servers, gives us the agility to be able to be far more adept in our business, and gives us a much better cost model, and only from that kind of a platform can we advance ourselves. So that had only come out just in October of 2012, and shortly in 2013 I'm up here talking about what would be real, and so saying that 2013 was really the year of software networking coming into play. And then I contrasted NFV with SDN, saying that they're complementary, but also indicating that it's possible that NFV was going to pick up a lot faster than SDN. And there were some reasons behind that. So just a couple of months ago, I went to Barcelona to Mobile World Congress. Anybody here been to Mobile World Congress? Anybody familiar with it? Mobile World Congress is the world's largest trade show for networking. And by world's largest, I mean there's nearly 2,000 vendors there. You used to hold it in Nice, they outgrew Nice, now they're in Barcelona. Nearly 2,000 vendors there, nearly 100,000 attendees, and it's only networking. It is intense networking show. And if you walked around any of the 8 buildings that housed any of the vendors there, you couldn't swing a dead cat without hitting an NFV sign. I mean, it was phenomenal. I have never ever seen a dynamic get that quickly adopted that fast. When SDN first came out, you go to Interop and everybody had SDN. I'm software-defined networking for analytics or something, and there wasn't anything there really. It was just a badge on a wall. But here at Mobile World Congress, it wasn't just that NFV was everywhere. It was everywhere and being demonstrated. And it was fascinating to see that happen. So, as far as prognostications go and looking into the future, I decided that either I'm incredibly acute in my vision, or I just have an amazing command of the obvious. And so, since I was only looking at about a year then, I decided this year I'm going to look at a little more than a year, and we'll talk about kind of an era. And we'll talk about SDN and its evolution, how it's come and how it's evolving, and what the impact really is on the industry. Because I'm really fascinated with how this is changing industry dynamics, how the opportunities are changing, how the new technologies are coming into adoption, and how customers benefit from it. So when you look at the evolution of SDN, I think we could all say that it started off with a protocol, right? It was you had to have a poster boy for this, and when OpenFlow came out, it was OpenFlow all day long. OpenFlow equals SDN, and that's just what SDN is. And I guess you have to start somewhere, and it was a good place to start, but things have evolved from that point, from protocol to SDN is a product, and it could be any type of product. I'm not going to specifically talk about any one here, but it could be an overlay, it could be virtual devices, it could be a variety of things. But we started with the protocol, then we went to actual products that you could deploy, and now what we're moving toward is the platform era in SDN. And this is when you're starting to look at the full set of abstraction from the infrastructure that's conducting the actions to the controller that is easing the management pain from that, to the orchestrator above that that's actually provisioning the infrastructure. And we're seeing that these platforms start to come into some kind of cohesion, but there's a pattern the way that these are all coming around. And that's what I think is really interesting to me. So when you look at the platform categories that are emerging, one way to look at this is to say, are they hardware-based platforms? Are they software-based platforms? And are they closed in the sense that, by that I mean proprietary, or are they open in terms of not just standards, but actually open and leveraging extensive amounts of open source? And what we're seeing is this population, this quadrant is beginning to populate here. And the first one that in no particular order is, I'll start here with the Cisco architecture, the ACI architecture, which has a variety of components, and I'm not going to walk through it, but you can see from their site and their materials what's there. You've got Cisco branded switches under there that have got NXOS in there, and they've got, some could be merchant, some could be taking advantage of the unique silicon that they've got, and then some software layers above that. So if I park that one over here and say that's really the one that's really hardware centric within, for the most part, a proprietary encasing. And then say the next one would be, software based, and this would be VMware. You've got NSX up there, and pretty much trying to draw all of the logic up into the software, just to the ultimate peril of the underlying hardware, as much as possible. If they could drive to white box it and make them, perfectly happy, because they want all of the logic into the software, and giving themselves the vendor power relative to the hardware vendors. So you park this one over here, and then you start saying, okay, you've got your proprietary side kind of lined up. Those are the two winners. So now we still are waiting, and this is the part of the industry that I think is a lot of fun, is we're waiting to see what's going to happen on the open side. There's a lot of activity happening in open, and open can mean a lot of different things. But this is where I think the industry is going to be filling out over the next months and years, which is, what are the open alternatives in the SDN platform era? And when you talk about openness in general, what would we say that would have to be? I'm going to talk just about software. This is a software-defined data center conference, so I'm just going to focus on that upper right quadrant of the open software side. What are the characteristics that would make for an open platform here? Because there's a lot of development that has to happen. First of all, what is that network operating system? It's got to be have really rich services. It can't just be switching, right? There's a reason that we have all the way up to layer 7. These services are important, and in virtualized environments, increasingly important, because you have to be able to manage with a lot of policy and a lot of detail inside of very compact virtualized environments. So L4 through 7, you can read this thing through here. I hope you can. Your eyes are probably better than mine. But one of the things it does imply is that as software, that you have to have the forwarding engine that has to be in the software has to be stateful, and this is an important distinction. Stateless is switching. And stateful is everything above that, anything that has to have memory and context around what it's doing. So stateful forwarding in a rich services platform is going to be crucial. When you move to the next one, which is the controller, really what you need to have in the controller level, again, openness. Openness is about choice. And you need to have heterogeneous support at the controller level. That means being able to support a multi-vendor environment. It means to be able to also accommodate third-party controllers. We're going to see architectures, SDN architectures, before the end of the year. You will see deployments of SDN architectures that actually have controller hierarchies in place because of the way that they're building out their networks, especially in the service providers. You will see this. I've already seen of some of them in prototype mode. So, being able to be heterogeneous, not just in terms of the vendor support that it has, but also heterogeneous with respect to other controllers and the ability to interface with that. And I think Open Daylight actually has a tremendous opportunity in this capacity, because it really is gaining a lot of traction in this regard. Above that, then you've got orchestration. And here, really, you need a very malleable framework. because what one person is trying to orchestrate can be very different than what another one is trying to orchestrate. You've got, again, the need for multi-vendor. It always has to be multi-vendor. It always has to give choice. And in the orchestration area, I think in the open arena, OpenStack definitely has a lot to say here. Still going through a lot of innovation, still going through a lot of adaptability. It's certainly not the only one, but in terms of the real openness and community-driven types of activity, that's a really good example there. And then ultimately on top of this is an ecosystem, because no one vendor is going to be able to provide you with everything that you want. And this is the nature of openness. You need to have interchangeability. If a vendor comes forward with a stack, an SDN platform stack, and says this is exactly what you need, it will solve everything, every problem that you've got, and you say, well, actually, I have a real preference for this one function for this other vendor over here, they should be able to plug that in. You shouldn't be able to stiff arm. You can't give somebody the Heisman here and say that it's my way or the highway. You know, openness is about choice. So I think the openness of the platform for the SDN platform is really going to have a lot of these characteristics. And the value of it is when you bring them together, this is how somebody can advance their architectures and kind of eliminate their lock-in and really enable a lot of innovation on their part. We see some really interesting network designs that happen from our customers because they have this much malleability. I've got a big NFV proof of concept going on across Europe right now that they couldn't even deploy until they first made some modifications to OpenStack. So what they really wanted was they wanted the network infrastructure, but the context was within a very malleable set of orchestration. And they could never have achieved their goal if they didn't have this kind of flexibility. So I think that this is really going to be an interesting area to watch the development of over the next months and year or two. Now, when we talk about software, I have a tendency to associate software with a server. There's software in boxes of every type. Every single device out there is a box of software in it. But when I talk about software, I tend to talk about the server side of the equation here. And you know, you've got a network device and you've got the server device up above it. And what's been happening really is kind of an interesting pattern is that the software value or the software capability has been working its way up into the server over time. And it's a bit of an eye chart, but I've tried to capture this dynamic. It's approximately right. I know it's not precisely wrong, but it's just about right. What's interesting is to see how this pattern has emerged. At least it's interesting to me. I hope I'm not boring you here. But the first movement into the server was really driven because of virtualization. And that sounds like a big duh moment, but you think about what it was. As the number of virtual machines inside of a given server began to multiply, you began to have this problem that two different applications, you used to have one application per box. It was easy to manage the traffic. How do you manage the traffic and the policies into that application? Easy, there's a wire that goes into it. That wire comes back to a physical box that does all of this wonderful goodness, right? Now you've got this box with two applications in it as running as virtual machines. Maybe one has to get communicated with under a certain set of policies and another one has to be communicated with a certain type of policy. How do you do that? Well, first of all, the first question is how do you get the packet to it? You've got the wire going into the box, packets are coming in. How does it know whether to go to virtual machine A or virtual machine B? And this was the camel's nose under the tent of software getting into the server. And of course the answer was you put a vSwitch in there. You know, it's your last hop, it's your last L2 hop, okay? Every hypervisor's got a vSwitch, they're commoditizing rapidly. So that was the first part that went in there. And once you got enough virtual machines in the box, then the question was, well, what about the L3 through 7 types of services that I normally have between applications? You know, if I need to firewall the traffic to this application, or I need to NAT the traffic on this application, or load balance this one, or put a special routing policy around there. And what happened was virtual network devices came into play, like virtual routers, virtual firewalls, that sort of thing, to be able to manage the traffic within the server the same way that you manage it from the outside the server. And that is really where the commercial adoption of Viata really picked up the most. And we saw that tremendously in cloud service providers. Very dense, fully virtualized, and being able to use these kind of controls inside the server the way that you did outside before. Then after that came the question of, okay, now I've got all of these network virtual devices. I'd like to be able to orchestrate them the way that I orchestrate my virtual machines. And this is when you look at an orchestration mechanism like OpenStack and say, this is great for storage, it's great from compute, but now it's time for us to start worrying about the orchestration of networking. This is about the timeline that you saw things like Neutron really starting to pick up. within OpenStack and networking becoming a formal component of the control. And then you said, well, now I'm starting to run into a management problem here. I've got a whole lot of devices out there. And that's where the SDN controller comes into play, which is the ability to drop some logic into the controller, have it parse that out, and push a bunch of commands all the way out to the end devices, or in this case, the virtual machines. And then there's yet one more shoe that's dropping here, and we're just starting to see this now, which is that's fine within a given server, but now I actually need to scale this kind of functionality across servers. I need to almost look like a layer, this network capability to almost look like a layer of middleware across servers, and just let me tap the services as I need to. And that's just starting to happen right now. So it's interesting to watch software's invasion into the server, and this to me is kind of some of the underlying patterning that's going on that's actually creating the beginnings of an open platform as well. Right now these are all discrete components, they're not really tied together too well, but for the most part they interface with each other. And I think the opportunity really is going to be to see how the industry comes around the real definition of an open platform within the server. So then I get to the interesting part about the industry. So what's going to happen with the industry? I mean, we know who the large incumbent vendors are. We know what their power is. And if everything stayed the same, you could pretty much prognosticate that things are going to continue in the same direction. But what if the customer buyer behavior changed? More importantly, what if a new type of customer began driving the predominance of the buying? Would that change the rules? And I suggest that it would, because what you're going to be seeing here is that the cloud service providers and telco service providers are going to be doing the increasing amount of the overall equipment buying to the point where they're going to be the dominant buyers of infrastructure as opposed to the classic enterprise, because they're either going to be farming it out to their clouds or the parts of their data center that they'll keep are the ones that are kind of persistent, the ones where they have unique applications where they really don't move to the cloud that well. So you see this idea that the service providers are actually going to be doing the bulk of the buying. So now the question is, what does the bulk of the buying have to do with all of this platform discussion? And that's where you get to the question of, well, what are their preferences? What do they like to buy? And it's interesting because when they came out with it, go back to the NFV story. It's practically the Württemberg thesis. This is like Luther nailing the thesis to the door of the church, right? They said, we do not want closed, inflexible systems. We demand open, software-based things that are running on COTS hardware. You can read the paper, and there's a lot of progress that's been made since then. So a couple of data points on it that are coming up here, but what is it about NFV, just in particular, that has been so appealing? NFV is a subset of SDN, if you want to. It's got these wonderful business benefits. It's much more agile. It's much more efficient. It's much more cost effective. They can spin up services, spin them down in a fraction of the time that it would take them in the hardware world. I think it was one of the guys from IDC, he said that in a former world, he said that spinning up new services in the telco world, he called it the law of the 3 2s. $20 million, 2 years, and too late. It took way too long to get something up and running. And then, and even if you wanted to prototype something, it was really rough. But now, you can basically, push buttons and light up software in various parts in just segments, test markets, and that sort of thing. It's got a lot of benefit to it. I've got a couple of eye charts here, but I'm just going to make a couple of points. So NFV in the adoption timing, this is I think from heavy reading. It just talks about how fast are carriers starting to adopt. And the first chunk across there is, you know what, I'm just going to pop down here for a second just to make the point. It was, are you going to be doing POCs, are you going to be doing trials, or are you going to be doing deployments? And then this is, have you already started? Are you going to do it within the next 12 months, within the next 2 years, past that? So just care about from this green line on. So for POCs, it's basically, yeah, we're already starting to do POCs. How about trials? Not almost as much, but almost as much. And then how about deployments? Yeah, within the next 12 months to 2 years, we're going to be doing this. Right? And this is the actual deployments of NFV. So we talk about NFV and the speed at which it's moving, and it's easier to understand because it's modular, right? It's modular consumption of things that already existed, but just in software form. So that's That's a pattern that's happening right now. And then when it comes to service providers and NFV and SDN, I kind of refer to this as the elephant mating cycle here, because it takes, it's done at a high level with a whole lot of yelling and screaming and takes 2 years to produce results. But but you get my point here, because you look at the adoption, you look at the plans of this, and this is, again, a bit of an eye chart, but you can see on the first column there, it characterizes how big the carrier is. And then across the columns, it says, you know, the nature of the questions. Are you going to be deploying NFV now? Are you starting to create a strategy? And when you start looking at the biggest carriers, they have the highest association of moving into the NFV spot. So back to my point, carriers are going to be driving the bulk of the buying. So if the customer buying behavior is starting to change, what's this mean to the industry and the kind of choices that they want to make? So this is just their adoption of NFV. The next chart is, what about your combined adoption of NFV and SDN? And basically they said, yeah, some of us are going to do it together, some of us are going to do it one followed by the other. But again, the biggest carriers, the biggest buyers are the ones that are going to be moving down this path. Then we get to the question of, okay, that's fine. So SDN is moving faster than NFV, or NFV is moving a bit faster than SDN in general. Now, what do you like? And the first question here is, you know, what about your virtualization platform? And they say, well, you'll see that these sum up to more than 100% because they have the option of answering more than one. But in general, look at, that's really interesting. Very, very strong showing by KVM in this environment. So again, SP is really liking the openness, not wanting to get boxed in. You know, they ask what kinds of other aspects of the tools. What about orchestration and tools? Well, you've got OpenStack really with a very strong showing in here. Other things like Chef and Puppet, so much more DevOps-y kind of a play. So again, you've got this affinity toward openness that the service providers have got. So as we talk about this SDN platform, this is the platform era. We've got the OS, the controller, we've got the orchestration above this. The closed hardware and software opportunities have, those holes have been plugged for the most part, I'd say. Now the question is on open. And the interesting thing here is going to be to watch how service providers are using these new technologies to springboard their way into the cloud, to have networks that are designed really more for the cloud. And all these benefits that should accrue from openness, you know, the elimination of vendor lock-in, really radically changing the economics in networking. And that's not just to say just the fixed price. I mean, you're going to see some really innovative business models around here, consumption-based business models. You know, the ability to not have to compromise between what I want and what I'm going to have to spend on, and really beginning to use the infrastructure as a competitive weapon. So I think it's going to be a very, very interesting next year or two to watch what happens on the open side of the platform for SDN, and we'll see if I'm invited back next year just how right or wrong I was. If I was wrong, then I probably won't have my job, so I'll be doing something else. All right, well, thanks for your time. I hate to stand between anybody and lunch.
Thank you, Kelly, we appreciate it.